Okay, so hi, we're City Science, and we're excited to give you an update of our AI generative design tool for low-cost district heating networks. We have two of our team on the call today, so Joe, our project manager, and Andy, our technical lead. I'll just give you a quick introduction to City Science. So City Science's main objective is to aid decarbonisation at the national, city, and building level scales. And we do this by building software tools, as well as consultancy services and research services. We focus these services on the three major CO2 emitting sectors of transport, domestic, and commercial. So there's a little bit of context for our district heating tool. As a landscape between 2014 and 2019, carbon emissions in energy production have decreased 54%. In industry have decreased 12%, but in buildings have increased 6%. The majority of energy used in commercial and domestic buildings is for space and water heating. So heating is the major obstacle for decarbonising buildings at scale. So there are two approaches for the UK to decarbonise heat in buildings. One is to reduce the amount of energy used, and the other is to decarbonise the heating source. And hopefully we do both together. The UK plans to address the shift to low carbon heating by a major scaling up of the number of properties served by district heating networks. So the government's 2050 target of 90 terawatt hours of heat served by heat networks per annum accounts for around about 20% of all domestic heat. So according to Hindu funding applications, only 25 large-scale district heating network feasibility studies have taken place in the last 3 years. Our modelling suggests that only 54% of these progress to build, providing the run rate deficit in our graph. The key question becomes, how are we going to plug this deficit, both via increasing the number of studies conducted and increasing the number progressing to build? So in phase one, we documented the common process steps in the design and commercialization of district heating networks, the stakeholders involved in each of those steps, as well as the stakeholder interactions. We focused in on design stages 1 and 2 as part of this process, and we utilized user-centric design to develop and test a value proposition around stakeholder key gain and pain points. So just to recap and run through some of our proposition. So we have improved network design, optimized based on user preferences, and this is done via our AI generative design tool. Drastically reducing design time, resulting in more designs to choose from. So we do this by a mixture of process automation and fast feedback cycles with end clients. Improve customer experience via clear reporting and access to designs earlier. The ability to design 5th generation heat networks, the identification of the most sensitive variables to design metrics, and so on and so forth. So in phase 2, we've continued to expand our list of users and key stakeholders. In phase 2, we have continued to utilize user research to refine and update our service offering with the help of detailed interaction with a selection of key local authorities and consultancies. We've been working especially closely with the Energy Systems Catapult Customer Insights team and local authorities to design a service level blueprint. And we've been working with a range of consultancies to help validate our tool and further refine our consultancy journey. Further details have also emerged of how the current district heating process and grant awards are changing. So currently, the two major grant schemes open to local authorities are the Heat Network Delivery Unit at the design stage. So that's this one here. So the Heat Network Delivery Unit is a grant open to local authorities in England and Wales to provide support in the planning stages of heat network development. So we're ensuring that our tool can be set up to have Hindu compliant outputs and that modeling methods adhere to the Heat Network Code of Practice. So the grant funding commercialization phase, though, the heat network investment projects, is changing. So HNIP is being replaced by the Green Heat Network Innovation Fund, with the full scheme starting in April 2022. So the grant is open to the public, private and third-party applicants in England, and it focuses on funding larger low-carbon heat networks. There are a range of gateway requirements for funding for the Green Heat Networks Fund, and we're ensuring our tool can be set up and selected at the design stage that satisfy these gateway requirements. So key changes to the design stages are also on the horizon. So the typical three-stage process were replaced by a zoning and feasibility process. So zoning studies are currently taking place in England and will change the way heat mapping and master planning are currently implemented. So rough zones will be applied to the whole of England, with zones designated where a critical mass of heat can be supplied by district heating networks at lower cost than other low carbon alternatives. Zones will then be refined based on local collection and data in this stage 2. So we are ensuring that our tool is integratable with proposed zoning data structures, models, and processes. Oh, sorry. The majority of our tool production to date has been getting the back-end model and data structures right, with increasing progression to visual elements of the tool. So for example, we've been working heavily on our underlying data ontology, temporary evolving heat demand model, heat sources and heat location models, energy center optimization, whole network simulation models, automated routing packages, financial and environmental packages, as well, of course, of our human-in-the-loop generative design processes. To test these models, we're undertaking benchmarking activities on real and simulated data sets. We're collecting data from existing heat networks, both in Portsmouth and Islington, so part of the Portsmouth network is shown in the diagram. And we're using this data to benchmark and refine our simulation models to ensure they have a grounding in real-world applications and data. We're then running our generative design tools on these existing networks to help quantify the benefits our tools can produce. In the case of Portsmouth, who are actively considering an energy centre replacement on their network, we're utilising the tools to produce a range of options suited to their preferences and constraints. In addition to real-world data, we're using simulated data to feed into our models to enhance the range of scenarios in which we can test our tools. So we're going to walk through a small selection of the capability of the tools produced as a result of MEDApps. We're only going to show a subset of the outputs, which is to give an overview of the tool, the number of outputs in a district heating network design typically being quite extensive. So all projects are able to draw upon our base maps. So under the hood, we're utilizing ordnance survey data, such as master map topology layers, site layers, and address-based data. And the reason for this is twofold. The data is generally richer, more complete, and of higher quality than competing sources. And future zoning of England and Wales will be performed using ordnance survey data. So to integrate with this, the system needs to use OS data. Our heat demand model estimates heat demand at the individual property level at hourly temporal resolution and by different end users. National and locally available data sources are utilized to produce default data, which is then superseded by further data collection. Heat demand data can be visualized at the building level as heat density or linear heat density maps, identifying promising areas for networks. Automated land classification is utilized for network routing. A number of classifications are produced, including dig type, ownership, and obstacle status. This latter includes things like utilities, buildings and rivers, etc. So these classifications are utilized by our network costing tool to estimate the network routing costs. Networks can either be drawn by hand, imported, or automatically drawn by our automated network routing tool. So LAN classifications and associated costs can be easily updated, and the network routing costs automatically updated. Or if the automated routing tool is rerun and a new optimized network configuration found. So as we've touched upon, heat demand is estimated down to the individual property level. Property level peak heat demands for different end uses are also estimated for sizing network components and sizing counterfactual heat generation options. So for example, how district heating networks compare with heat pumps distributed at individual households, for example. So we can select a boundary within which we wish to explore a network opportunity. And we'll explore heat network opportunities around the RD&E hospital in Exeter. The tool can add connection statuses to our network, i.e. required, potential, or not connected. Connection statuses can be assigned by building type in the area of interest, uploaded for a file, or selected automatically. So data can be uploaded to our tool, and this can be done for a number of different purposes. So as mentioned, to supersede existing default data, to add in new features such as buildings. New buildings can be either updated manually or uploaded via a file, or to upload an existing network we want to modify or extend. So our tool can deal with both new and existing networks. So when launching our AI generative design optimizer, we get the following GUI, and this allows us to set up a number of things for optimization. So for example, we can set up network constraints on the left. And these ensure that network solutions are found which lie within the range of values that are specified. This is an example of how we would set up our optimizers to find solutions which satisfy the Green Heat Network Fund gateway requirements. So secondly, we can set objective functions that we wish to include, and these are the things that our optimizer will try and find minimum and maximum solutions for where possible, although conflict will arise where these competing. So the min max here are placed, not to be confused with what we're optimizing for. The min and max here are just are optional and just to help speed up our optimizer if they're known. So the third column is what's known as decision variables. These are things that we allow our optimizer to change when searching for new solutions. So for example, we might want the optimizer to try out different heat generator options, but we may have a pre-specified type of heat storage devices we want to use, i.e. water storage. We can both pick this at a high level or go down into a further level of detail. And for example, specifying which type of heat generators can be tried, i.e. heat pumps or biomass boilers, for example. So the optimizer will then go off and work very hard in the background to generate solutions to our specified setup. In a graph, we like to show for different types of solutions generated as a parallel coordinate plot, which allows us to see a spectrum of solutions generated for our chosen objective functions. So a list of generated solutions in tabular form is also generated on the right, and we're currently updating the GUI so that we can filter the solutions by both objective functions, constraint values, and other key parameters, i.e. the heat generator types, for example. So if we decide we want to change something in the objective function, constraints, or decision variables, we can update and rerun our optimizer. So we can choose a particular solution that we want to explore in more detail. And we output a range of summary details for each solution, split into solution statistics, key network KPIs, as well as financial KPIs. So we're currently tailoring our KPIs to output. We're currently tailoring our KPI outputs with our project stakeholders, and all of our solutions can be output to Excel or geographical files, which can be either passed on to clients or key stakeholders used internally for further analysis, or used as evidence basis for grant funding. We're currently testing outputs for these purposes. So a key part of our value proposition is being able to provide a financial overview from a number of different stakeholder perspectives. And hence we can examine financial analysis for a number of different contract types and roles. So for example, we can output tailored financial analysis from the project owner's perspective, which provides information such as IRR and net present value for the overall project. We're currently tailoring these outputs so they're Hindu and Green Heat Network compliant and can be fed into funding applications. We can also look at the relevant business case from site developers' point of view as another example, and these outputs can be used to satisfy key stakeholder requirements. So all of our solutions include sensitivity analysis, enabling key risks to be flagged. The tool is able to produce sensitivity analysis over a number of variables, such as fuel price, cost of counterfactuals, or capital cost as a few examples. So just to go through some of our stakeholder feedback. So in terms of process automation, it's estimated that we'll be able to, using the tool, we can significantly speed up feasibility studies. We can reduce the cost of those feasibility studies and educate and enable less experienced users to test feasibility. We can improve our solution designs. We can reduce the number of iterations required, increase success rate of feasibility studies, and allow 4th and 5th generation heat networks to be designed. And we can tailor our contracts and roles to key stakeholders to get increased project stakeholder buy-in. So our phase 2 objectives are really to develop a fully developed DHN solution and up to TRL level 8 to further refine further scope refinement and beta testing to engage partners and users to ensure our tool delivers the value proposition and perform public and beta testing. And also to evaluate solution validity. We want to test district heating network design outputs against industry benchmarks. Thank you very much.
Great presentation. Thank you, Andy. Thank you very much. And we have now Q&A, and we have a first question in the chat. I will invite all the participants to write your questions in the chat, questions, comments. The first question that we have is, how is this tool going to be available to customers? Is it going to be on cloud-based, on-premise software?
Yeah, so I think we've got a number of different ways that we're going to output information. So we're going to allow our tool to have API access, for example. So we can people can use different, because it's very modular. So people can use different modules, and we want it to be interoperable with other tools. So people can call APIs, for example, and get data back. And the longer term plan is also to develop, a full application. So we're coming up with minimum viable products within modules and also a fuller application. Right. And the fuller application event should be via web service. Yeah.
And speaking about the district heating network design process that you mentioned, did you find any differences between the different countries in the UK, like between, for instance, England and Scotland and Wales? Do you have to take different approaches?
Yeah, I mean, so yeah, so England and Wales are reasonably similar, at least at the moment. Scotland is quite different. Both a little bit in terms of methodology. So for example, Scotland already has an existing heat mapping tool, for example, we want to integrate with. Also in terms of how we can access data in Scotland, that's quite different. So in Scotland, you've really got to come up with an agreement with the government to access data, whereas in the UK, you can access there's a lot of publicly available data, which is easy to access. Scotland, I think they're already further ahead than England and Wales with their zoning studies. So we're looking carefully at what Scotland have done, and also how England and Wales are slightly altering their zoning studies and changing suit. Yeah.
I see. And and will you be? Do you have a roadmap of, let's say, different areas that you will be targeting? Will you start from England and then Scotland, or will you start launching this product in both countries at the same time?
I think so. We're aiming to launch in both. Initially, we perhaps thought Scotland because they're maybe further ahead, but we also think there's current demand in England. So from stakeholders we've engaged with so far, there is certainly there is an immediate commercialization route within England and Wales, but we're following up in Scotland, and we think they're further ahead in terms of where they're at in terms of scaling up their district heating networks. So both I think at the same time is probably the answer to that.
Okay, great. And going back to one of the say numbers or quantitative measures that you presented, I read on one of your slides that this tool can save between 50 and 70% in terms of time spent for the feasibility study. Did you manage also to quantify the economic benefits, how much that reduction could be in terms of from an economic perspective?
Yeah, I think
study?
We should, probably what I should have clarified there is there are different parts of the feasibility study. So there are stakeholder engagement aspects and there are technical aspects. So certainly between 50 and 70% on the technical aspects. We envision it will increase the stakeholder interaction, reduce the stakeholder interaction time via producing key outputs, which will overcome those barriers as well. In terms of quantification, yes, we do have a quantification, and I can't quite remember off the top of my head from phase one what that was, but yeah, I can find out.
Right, no worries, you're fine. And I'm not sure if we have any more questions here in the chat. Let me see, now just some comments, positive comments, we'll say. And yeah, well, thank you, Andy, for your presentation. If any of the participants has any additional questions, please drop them in the chat. And I'm sure the Andy and City Science team will be on the call for the rest of the event. So if you have any questions later on, please let us know. And
thanks very much.
Thank you, Andy. Thank you for your presentation. We will now have a break, and we will be back at 10:45. We will have a 10 minutes break. Thank you. Thank you, everyone.